Hey guys, in today's session I want to solve another problem in heat transfer. But as always, let me introduce the reference, which is 10th edition of book Heat Transfer from J.P. Holman. I'm going to go to page 64 to solve problem number 30. Okay. It says derive an expression for the temperature distribution in a plant wall having uniformly distributed heat sources and one phase maintained at the temperature T1 while the other phase is maintained at the temperature T2. The thickness of the wall will maybe taken as 2R. Okay. Okay. Let's solve it. Get to the whiteboard and solve. Okay. It says that we have a wall which thick of that is 2L, and we assume this is origin of X, this line. Okay. Then we know from boundary condition that problem set boundary condition we know T equals T1 when X equals, for example, minus L, okay, which is here, minus L, T1 in this wall, and this wall T2 X equals L, then T equals T2, okay. This is left and this is right of this wall, okay. For temperature distribution we should write a formula. Our formula is ln square of temperature divided by ln of x square, okay, plus Q dot over K equals 0. Q dot is generation source and K is thermal conductivity, T temperature, and X this is distance. Then this is our formula, main formula. We should solve this formula, okay. From this formula I can write on 2T equal Q dot minus Q dot K multiplied by dx squared, okay. If I integrate from these two sides of this equation 2 times, I will have equation of temperature, okay. Let's do it. Then ET equals minus Q dot over K X, okay, dx plus c1. Okay, again I need t, but there's a differential of that. Let me integrate another time, one time more. T equals minus q dot, or k are these two variables are constant, not these two not actually, we assume k is constant, okay, and q dot is constant and not dependent of temperature or x, okay, but in real this is not true because k is function of temperature, okay, but we assume for simplification we assume these two are constant, and would be x squared, and we need a 2 here, okay, plus c1 x, sorry, just made a mistake, plus c1 dx, okay, multiplied by plus c2, okay. This is our formula, but we don't know these two constant. We should add them, okay. Let me highlight this main formula. This is our formula, okay. Then let me continue with solving it for putting boundary condition in this formula to solve C1 and to calculate C1 and C2, okay. Then I will put these two boundary condition into this formula. Then let me write T1 equals minus q dot over 2k. In place of it, I should put minus L, which will be L2, okay, minus C1 will be L, okay. Okay. Sorry, it will be minus, yeah, because x is negative. Then plus C2, okay. And for the second boundary condition, what can I write? T2 equals minus q dot over 2k, x squared will be L squared, and plus C1L, because I should put L in place of x, plus C2, okay. Then I should use these two equations to find C1 and C2. Am I able to do that? Yeah, because I have two equations. I can earn and calculate C1 and C2. Okay? Then first I subtract T1 from T2. Okay? If I do that, the sign of this equation will be inverse and plus this equation. Okay? Then these two terms, I don't have these two terms because these two terms we eliminate each other, but I have 2 multiplied by these terms, then 2C1L, and I don't have these 2. Okay, this is L. Then C1 equals T2 minus T1 over 2L. Okay? This is one of formula I want. From this one, I can conclude if the temperature of right wall of the element of the wall, the right side of that will equals to temperature of left one, it means T2 equals T1, then C1 equals 0. Okay, but this is not T2 not equal to T1. Okay, and for the next I would have an addition from T2 plus T1 equals, okay, minus Q dot L2 over K, because I have two terms of these with the same sign. Okay, well, I don't have these two because these will eliminate each other, and I have two of these terms plus 2C2. Sorry to okay. Then I can find, I will write it here, I can find C2, which is T2 plus T1, okay, plus Q dot L2 over K, all of this divided by 2, because this C2 has 2 in denominator. Okay, this is C1 and this is C2. Okay, I will put C1 and C2 in main formula. Okay, then what do I will have? T equals, let me change place. T equals minus Q dot x2 minus Q dot x2 over 2K plus T2 minus T1 over 2L x, okay, plus C2, which is this one. I will write it in this way: T2 plus T1 over 2 multiplied by Q dot L2 over 2K. Okay, but these terms and these terms are the same likely. Then I will write, if I write it in this way, 2K L2 minus x2. Okay, these two terms are these two, plus T2 minus T1 over 2L plus, sorry, it needs an x here, plus T2 plus T1 and a 2 in this denominator. Okay, this is distribution, temperature distribution, and answer of this problem. Okay. Then Q dot is generation source, K is thermal conductivity, X is any point. For example, I want to find this in this section, and X will be, for example, L over 2. Okay, I will put L over 2 in place of X, this X, and these two temperatures I have them. Okay, so this was a formula for and the answer of this problem. But let me show you. Let me show you this formula in the book. The same situation, plan wall with heat sources, exactly the same as I drew for you. This is Q dot, which is heat generated per unit volume. Okay, and this center line is X equals 0, and this is a symmetric condition, but we didn't have it in here because T from these two walls are not the same in our problem. Okay, and this is the formula. Differential equation that governs the heat flow is like something that we draw. Okay, then it was another session for solving another problem in heating transfer. Take care and have a good one. Bye bye.